Your AI has never seen your private documents. It was not trained on your company files, your research papers, your meeting notes, or that 200-page PDF sitting on your computer. And yet, you upload those files, ask one question, and seconds later, the AI gives you a surprisingly accurate answer. So what is actually happening? Did the AI suddenly learn everything inside your documents? Not exactly. What you are seeing is usually powered by RAG, short for retrieval, augmented generation. It sounds complicated, but the core idea is simple. Normal AI is taking a closed book exam. RAG lets it open the book before answering. A language model normally answers using information stored inside its parameters. During training, it reads enormous amounts of text and learns patterns, facts, language, and relationships. But once training ends, that knowledge has limits. The model may not know recent information. It does not automatically know your private data. It can forget details buried inside long documents. And sometimes, when it does not know the answer, it still produces something that sounds believable. RAG changes the process. Instead of asking the model to answer immediately, the system first searches for useful information. Then it gives that information to the model. Then the model answers. Retrieve first, generate second. That is RAG. Let's say I upload a 500-page product manual and ask, how do I force the device to restart? The AI does not usually read all 500 pages from beginning to end every time I ask a question. That would be slow, expensive, and unnecessary. Instead, the system prepares the document in advance. First, it breaks the document into smaller sections called chunks. One chunk might explain how to reset the device. Another might explain software updates. Another might cover battery problems. Another might contain warranty information. The system now has hundreds or thousands of smaller pieces instead of one giant document, but it still needs a way to understand what each piece means. That is where embeddings come in. An embedding is a numerical representation of meaning. Think of it as a location on a giant map of ideas. Sentences with similar meanings appear close together on this map, even when they use completely different words. For example, how do I restart the device? And what is the reboot procedure? Use different language, but they mean almost the same thing. Their embeddings would likely appear close together. A sentence about the refund policy would appear much farther away. The RAG system creates an embedding for every document chunk and stores those embeddings in a vector database. Then, when I ask a question, the question is also converted into an embedding. The system compares my question with all the stored chunks and looks for the closest matches, not the closest words, the closest meanings. This is important because traditional search often depends on exact keywords. If the document says, reset the device, but I ask how to force a restart, a basic keyword search may miss the answer. Vector search can still find it because it understands that reset, restart, and reboot are closely related concepts. Once the system finds the most relevant chunks, it places them inside the prompt sent to the language model. The model may receive something like, use the following information from the product manual to answer the question. Then the system includes the section explaining that the power button must be held for 10 seconds. Now the language model generates a clear response. To restart the device, hold the power button for 10 seconds until the indicator light flashes. The model did not memorize the manual. It was temporarily shown the correct paragraph. That is the key idea. RAG usually does not give the model new permanent knowledge. It gives the model temporary access to external knowledge exactly when it needs it. I like to think of this as a partnership between a librarian and an analyst. The retrieval system is the librarian. It searches through thousands of pages and finds the right material. The language model is the analyst. It reads the selected material, understands the question, connects the information, and explains the answer. The librarian finds the evidence. The analyst turns the evidence into a useful response. This is why RAG is now used almost everywhere. A company can connect an AI assistant to internal policies, employee handbooks, technical documentation, customer records, training materials, and support articles. Instead of manually searching through folders, employees can ask normal questions. A developer might ask, how does authentication work in our internal API? The system retrieves the relevant technical documentation. A support agent might ask, is this customer eligible for a replacement? The system retrieves the warranty policy. A researcher might upload dozens of papers and ask which studies found similar results. A student might upload lecture notes and ask for an explanation. RAG turns a collection of documents into something closer to a searchable conversation. But there is one important warning. RAG does not automatically make an AI correct. A RAG system can fail before the language model even starts answering. The biggest failure point is retrieval. If the system finds the wrong information, the model receives the wrong evidence. And a powerful AI using the wrong evidence can still produce a very convincing wrong answer. Imagine I ask how to reset a device, but the system retrieves a section about updating the software. The model may try to answer using that unrelated text. The response may sound professional, but the foundation is wrong. This is why document preparation matters so much. Chunk size matters. If chunks are too small, important context can be separated. One chunk might say, "This feature is supported." The next chunk might say, "Only on the enterprise plan." If the system retrieves only the first sentence, the answer becomes misleading. But if chunks are too large, they contain too much irrelevant information, making search less precise. Developers have to balance context and accuracy. Metadata also matters. Imagine a company has two versions of the same policy. One is from 2024. The other is from 2026. Both may look relevant, but only one is current. A good RAG system can filter by date, product, region, department, document type, or permission level. It needs to find not just relevant information, but the correct and authoritative information. Another problem is ambiguous questions. Suppose I ask, "How do I reset it?" What does it mean? A strong RAG system may use the conversation history to rewrite the question before searching. Instead of searching for, "How do I reset it?" it may search for, "How do I reset the Model X router?" That small change can dramatically improve the result. And then there is hallucination. Even when the correct text is retrieved, the language model may still add information that was never in the source. Developers try to reduce this by giving strict instructions. Answer only from the provided documents. Do not guess. Say when the information is unavailable, show citations. Citations are especially useful because they let users check where the answer came from. But even citations are not a guarantee. An AI can retrieve the right document and still misunderstand it. So in high-risk areas like law, medicine, finance, or security, human verification still matters. Another common question is whether RAG is the same as fine-tuning. It is not. Fine-tuning changes the model. You train it on additional examples so it behaves differently, follows a specific format, or becomes better at a certain task. RAG does not normally change the model's parameters. It changes the information available to the model during the question. Here is the simplest way to understand the difference. Fine-tuning teaches the AI how to respond. RAG gives the AI something to read before responding. If I want an AI to always use my company's writing style, fine-tuning may help. If I want it to answer using the latest company policy, RAG is usually the better solution. Policies change, products change, documents change. With RAG, I do not need to retrain the entire model every time information is updated. I can replace the old document, add the new document, update the database, and the AI can immediately retrieve the latest version. That is one of the biggest advantages of RAG. The language model provides the intelligence, the external database provides the knowledge, and the knowledge can be updated without rebuilding the intelligence. Modern RAG systems are also becoming more advanced. Many now use hybrid search. That means combining vector search with traditional keyword search. Vector search is great for meaning. Keyword search is great for exact names, error codes, serial numbers, legal phrases, and technical terms. Using both often gives better results. Some systems also use reranking. The first search might retrieve 30 possible chunks. Then another model reviews those results and chooses the best 5. More advanced systems can perform multiple searches. Imagine asking, "How did our refund policy change between last year and this year?" The system may need to retrieve the old policy, retrieve the new policy, compare them, and then create a final answer. At that point, RAG starts to look less like simple document search and more like automated research. The system can break a question into smaller questions, search multiple sources, compare evidence, and search again when something is missing. But the core principle never changes. Do not force the AI to remember everything. Give it the right information at the right moment. That is why RAG matters. Large language models are excellent at understanding and generating language, but their internal knowledge can be outdated, incomplete, and disconnected from your private information. RAG gives the model evidence. It gives the AI access to documents it was never trained on. It allows companies to update knowledge without retraining models. It makes answers easier to verify, and it gives users more control over which information the AI is allowed to use. So when an AI appears to understand your files, it has not magically absorbed your entire document library. Your files were divided into chunks. Those chunks were converted into numerical representations of meaning. The system searched for the sections most relevant to your question, and the language model used those sections to produce the answer. The AI did not suddenly know everything. It simply knew where to look. And that is the real power of RAG.